Okay, you guys, we're doing yet again another angle proof, which the more the merrier, right? I totally agree, you guys. This is about to get exciting. Okay, so I'm given that angle 1 and 4 are congruent, so I'm going to mark my picture. 1 and 4 are congruent. And I'm trying to show, so I can't assume this yet, but I'm trying to show that angle 2 is congruent to angle 3. Sorry, that should be two little arcs. Sorry, guys. So I'm trying to show that these two bad boys are congruent. So, again, I have to use different angles in my picture to help me eventually show that 2 and 3 are congruent. Okay, but anyways, let's get going, you guys. So, what do I always write first in my proof? I do, in fact, always write the given. So, the given says angle 1 is congruent to angle 4 by the given. Holy hot dog. Let's keep going. Guys, so I'm trying to show that 2 and 3 are congruent. Now, I already know 1 and 4 are congruent, so maybe if I could show that either 1 is congruent to 2 or 3, or if I could show that 1 and 4 somehow are congruent to 2 and 3, that would mean that 2 and 3 have to be congruent to each other. So, do you guys see a way that I could show like 1 is congruent to 3, or 4 is congruent to 2, or anything kind of like that? Well, if you guys look in your picture, what types of angles are angle 1 and 3, as well as 2 and 4? Do you guys see this X that is appearing? Do you spot the X right here? See the X? Okay, so which types of angles form at the X? Nice job, you guys. It would be vertical angles. So I know for a fact that 1 and 3 are vertical, as well as 4 and 2. And I do know that vertical angles are congruent. So that will help me get a little bit closer to showing that 2 and 3 are congruent. So my next step, I'm going to say, first I have to just declare that 1 and 3, as well as 2 and 4, are vertical. So I'm going to say angle 1 and 3, angle 1 and angle 3, as well as, or I'm going to put a slash, angle 4 and angle 2 are vertical angles. So they're vertical angles. And I know that because vertical angles are created when two lines intersect and they're directly across from each other. So I'm describing what it means to be a vertical angle. So this would be the definition of a vertical angle. And we also know a property, or we can apply the vertical angle definition by saying, I know that these two are congruent as well as these two. So I know that angle 1 is congruent to angle 3, and angle 4 is congruent to angle 2. And since I'm applying the definition of vertical angles, or giving you a property about vertical angles, what would be my reason for sharing? Sorry, I tried to say saying and share at the same time and it just came out funny. Anyways, so since 1 is congruent to 3 and 4 is congruent to 2, what can I use to say that this is true? I'm applying a property of vertical angles. This would be the vertical angle theorem. Nice job, you guys. Vertical angle theorem. Nice. Okay, so I want to show that 2 is congruent to 3, which I can actually already show that from this line, which is pretty insane if you ask me. That's pretty cool. Okay, so I need to start with 2, because I'm trying to show that 2 and 3 are congruent. So if 2, and I'm actually going to use, when I do this, I'm going to use this line and this line to show that angle 2 is congruent to angle 3. Like, we can already be done with this proof, but that's actually kind of making me sad because I don't like my proofs end. It's quite depressing. But anyways, I need to start with 2. So if 2 is congruent to 4, and if 4 is congruent to 1, and if 1 is congruent to 3, doesn't that mean that 2 and 3 should be congruent? Precisely, and the way I said it sounds more like the transitive property. But technically, you guys, this could also be substitution because since 2 is congruent to 4 and 4 is congruent to 1, I could replace 1 with the 2. Okay, I'm sorry. Yeah. Since 2 is congruent to 4 and 4 is congruent to 1, I can replace the 2 with the 4. So we know 2 is congruent to 1. And since 1 is congruent to 3 and we now know 2 is congruent to 1, I could replace this one also with the 2. So kind of using the transitive property, we can also use the substitution property, which is really nifty. Substitution property. All right, and guess what, you guys? That's it with that proof, which is really depressing. I'm still happy that we did a proof, though, so I'm going to do a happy face. So way to go, you guys. That was excellent.